Ever stop to think about the hidden link between the concrete under your feet, the planes flying way overhead, and the spread of a virus? Well, today, we're diving deep into how the very way our world is built, from the heat rising off our cities to the networks that connect them, might just be shaping the pandemics of our future. Okay, let's just jump right in with a pretty stark fact from the World Health Organization. As we've built up these huge, crowded cities, we've put billions of people at risk for diseases like dengue fever. And get this, reported cases of this mosquito-borne illness have shot up by a staggering 8 times since just the year 2000.
And that really gets to the core question we're asking today. In our rush for growth and connection, are we unintentionally creating the perfect superhighways for diseases to not just survive, but to thrive on a global scale? To get our heads around that, let's first zoom way in, down to the micro level. We're going to look at a really fascinating case study on dengue fever to see how the physical layout, even the temperature inside a single city, can completely change the game for how a disease spreads. But first things first, we need to talk about this thing called the urban heat island effect. Just picture it. All the concrete, all the asphalt, all the buildings in a city, they soak up the sun's heat all day and then radiate it back out. This makes the city center a lot hotter than, say, the leafy suburbs or the countryside around it. It literally becomes an island of heat. So, researchers in Thanjavur, India, had what seemed like a really logical idea. They used satellite images to map out the city's temperature, right? This chart shows their model. You can see the hottest zones in red and yellow. The thinking was pretty simple. Hotter areas mean more mosquitoes, which means more dengue. So you'd expect to find most of the cases right in those red-hot zones, wouldn't you? Well, the data told a completely different and, frankly, a much more interesting story. So where do you think the real hotspots for infection actually were? Get this. Only 30.2% of the dengue cases were found inside the city's very hottest urban heat island zones. That's it. So the vast majority, nearly 70% of infections, were happening somewhere else entirely. So what's going on? Well, it turns out there's kind of a Goldilocks zone for these dengue-carrying mosquitoes. Yeah, moderate heat is great for them. It helps them and the virus inside them grow faster. But the extreme heat in the dense city core, we're talking over 40 degrees Celsius sometimes, is actually too hot. It can literally cook them. So the real danger zones were those moderately warm fringes of the city. And this is the big takeaway here. The study concluded that we can't just keep building cities for our own convenience. We have to start thinking about designing them to be unfriendly to diseases. That can mean more parks and green spaces to cool things down, better drainage so mosquitoes can't breed. It's a whole new way of looking at public health. Which brings us to our next big question. Okay, so we've seen how the layout inside a city is a huge deal. But what happens when we zoom out and look at the massive web of travel and trade that links all of our cities together? All right, let's zoom back out, way out to the macro scale. Scientists have built these incredibly powerful models to understand how a small outbreak in one place can explode into a worldwide crisis. And it turns out, comes down to understanding networks. This is how they see the world now. It's not just a map of countries. It's a network of nodes and links. Each city is like its own little cluster, a module with tons of connections inside it. And then you have the highways, the train lines, the flight paths. Those are the bridges connecting all these different city clusters together. Here's a really simple way to picture it. Imagine every city is an island. An outbreak is like a fire starting on one of those islands. Now, if that island is totally isolated, the fire might just burn itself out. But if it's connected to all the other islands by a whole bunch of bridges or travel routes, that fire can jump, and pretty soon the whole archipelago is on fire. And here's where it gets really interesting. These network models show us something critical. As a virus gets more and more infectious, that's what you see on the horizontal axis here. The size of the outbreak doesn't just grow smoothly. Nope. This graph shows there are actually 2 distinct tipping points, 2 moments where a tiny change causes a massive explosion. So that first tipping point, that's when you get a local outbreak. The virus is contagious enough to spread like wildfire inside a city, but it's not quite good enough at jumping to the next city. It stays contained. But that second tipping point, that's the big one. That's when you have a global pandemic. The virus is now infectious enough to make that jump, to use those bridges between cities, and it spreads across the entire network. And that's why understanding these 2 thresholds is so important. It's basically a playbook for how to fight back. It tells us exactly which levers we need to pull to stop a local fire from turning into that global inferno. So the model basically gives us three main levers we can pull. First, there's the social strategy. That's things like masks and social distancing that just make it harder for the virus to spread from person to person. Second, you've got local quarantine. That's about thinning out the connections inside a city. And third is global quarantine. That's about cutting the bridges between cities, like with travel bans.
Seems pretty straightforward, right? But here's the kicker the model reveals. Timing is absolutely everything. Does it really matter if we act on day 10 versus, say, day 50? Oh, it's night and day. Seriously. Look at the graph on the left. That's an outbreak that's just allowed to run wild. It grows exponentially. But now look at the one on the right. See that bottom green line? That's what happens when you act early. The spread just flatlines. You snuff it out. The other lines show what happens when you wait just a little bit longer. And you can see how much bigger that fire gets. Acting early isn't just important, it's essential. Okay, so let's tie this all together now. What these two different areas of research really show us is that we have to be thinking about public health on two completely different scales, and we have to do it at the same time. On the one hand, at the micro scale of our individual cities, we need to start designing our spaces to be less friendly to diseases. But on the other hand, at the macro scale, we have to be just as smart about how we manage the giant networks that connect all those cities. It really is a profound shift in thinking. It's not just about reacting with medicine after the fact. It's about proactively designing healthier systems from the ground up. And this leaves us with one last big thought to chew on. Every new building we construct, every new road we pave, every new flight path we create, it's a choice. So as we continue to build this increasingly urban and hyper-connected planet, are we actually going to start consciously designing for health and resilience? Or are we just building wider, faster, and more efficient pathways for the next pandemic to travel?